Part 5 of the Strategic Level Risk Assessment for Fire Behavior Specialists is Effects Analysis. In this section, we'll discuss the use and development of an effects analysis, including methods to estimate potential fire effects on values at risk, and tools to evaluate air quality impacts of a fire. If risk is the likelihood of the hazard adversely affecting values, then the extended risk assessment will be more robust if it includes an effects analysis, which identifies how values are affected by wildfire, essentially looking at the combination of the values element and the hazard element. To do this, we analyze the value's susceptibility to varying levels of fire intensity or flame length as a surrogate for fire intensity. For example, what are the consequences if value X is impacted by flame lengths less than 4 feet? Not all values will be adversely affected by exposure to fire. Some values can withstand exposure to lower levels of wildfire intensity, and other resources may actually benefit from a high fire intensity. Risk is generally associated with negative outcomes. Conversely, an event that has the potential to yield positive results can be viewed as an opportunity. An effects analysis may be included in the extended risk assessment to address management concerns, both risks and opportunities, such as, if the fire reaches value Y, can we still meet the protection objective for value Y? Or, what are the opportunities to manage the fire to meet land management objectives? Or, will the fire move that drainage closer to the desired future condition, or will it cause uncharacteristic effects? Or, what will be the impact of smoke on the local community? Admittedly, given the limitations of the tools available to us and limited time available to complete analyses on a wildfire incident, any effects analysis not completed during pre-planning for the fire season will be rudimentary at best, but it can still be useful for decision-making. Consider the usefulness of these two examples of a basic effects analysis. In the first example, the FS Pro run for the next 14 days predicts a 60 to 79% probability that the fire will reach the recreational cabin on Sailor Creek. If you add an effects analysis of the Sailor Creek cabin to this probability assessment, it can paint a different picture for the decision maker. Consider this. The recreational cabin on Sailor Creek has a non-combustible cement board siding with a 2-foot-high stone foundation and a metal roof. Moderate intensity fire, defined as flame lengths greater than 4 feet, in close proximity to the house could cause some scorching, but none of the vegetation within 20 feet of the cabin will support flame lengths over 2 feet, and the sparse understory and foliar moisture content will not support crown fire under current and predicted fuel conditions. That statement helps the decision maker with a totally different picture. In the second example, the current FS Pro output puts the probability of the fire reaching the South Fork commercial timber sale at 60 to 79%, and the Snake Plateau commercial timber sale at 20 to 39% in the next 7 days. Would fire managers be likely to deploy resources differently if the extended risk assessment included the following effects analysis? The South Fork commercial timber sale is mostly flat, and the surface fuels won't support crown fire or surface fire flame lengths in excess of 1 to 2 feet under anything but 99th percentile weather conditions. We are at the 76th percentile now, and the fire season is already past the 50th percentile season-ending date. Tree mortality for the commercial species in the South Fork is expected to be less than 5%, if flame lengths are less than 4 feet. The Snake Plateau timber sale, however, is on the 30% south-facing slope with a brushy understory, and current fuel conditions could support short crown runs if the fire spreads in that direction. Tree mortality may exceed 80% under these conditions. The effects analysis that I just read more clearly describes how the values, the timber sale, will interact with the hazard, which is the crown fire or a surface fire less than 4 feet, and emphasizes the point that for some values, some fire is acceptable. For this example, fire behavior modeling analyses from the short-term fire behavior modeling system using the 76th and 99th percentile weather conditions could quantitatively support these fire type and flame length predictions. The fire's impact on air quality can also be included in an effects analysis. Air quality effects of a wildfire should be considered in 4 key areas: firefighter health and safety, transportation safety, public health and safety, and economic social impacts. For firefighters, smoke can pose a safety hazard through exposure to carbon monoxide, which can, with high or extended exposure, lead to impaired decision-making or more severe effects. If smoke is persistently present in the base or spike camps, the potential for this impact should be planned for and potentially mitigated. Continuous smoke exposure can reduce crew and personnel productivity and increase susceptibility to infectious disease such as camp crud. In terms of transportation safety, decreased visibility from smoke can pose a direct risk to the public and fire personnel. Drainage of smoke into valleys with roads or highways, smoke combining with other meteorological conditions to reduce visibility, and smoke impacts to aviation operations are all important considerations. Wildfire smoke is composed of a cocktail of different irritants and gases and particulates, which is why it can be harmful to our health. Impacts of wildfire smoke on public health can range from levels that are a nuisance to life-threatening for those who are sensitive. Informing the public in advance has been found to be an effective way to reduce exposure. Poor visibility can also negatively impact scenic resources for many miles around the fire, which can lower visitation rates at scenic areas and affect the local tourism economy. The public is interested in the air quality impacts they could be exposed to, and they expect local air quality regulators to help address the situation. Some impacts can be mitigated to a degree if the risk assessment recognizes this hazard. A new position available to an incident management team or to the agency administrator is called the Air Resource Advisor. This person can provide key information about the impacts of the projected wildfire smoke. The Air Resource Advisor can assist in the risk assessment process and can coordinate with the local air quality regulatory authorities and health departments. Air Resource Advisors can be ordered when needed through ROS and are trained to address the key air quality impacts of wildfire smoke. Air quality specialist positions are also in many land management agencies and can assist in addressing smoke from wildfire or initial assessments. Another useful resource is the local air quality regulators who can help address the impacts on public health. As a fire behavior specialist, your fire spread predictions are used by Air Resource Advisors so they can make smoke predictions. Analyzing the risk of adverse air quality due to wildfire is a complex process, but there are many tools available in WFDS at the firesmoke.us/WFDS website, as well as external websites like the EPA's Air Now. Specialized modeling can be accessed through Air Resource Advisors who can deploy air quality monitoring equipment to potentially impacted areas. Particulate matter, or PM 2.5, is an EPA-regulated pollutant, and it can be monitored through the use of one of the smoke monitoring kits available through ROS. It's critical to identify the potential air quality effects and address them proactively to allow for mitigation and public response by those who wish to reduce their personal smoke exposure. After a community is inundated with smoke for weeks, air quality becomes a more complex social issue and therefore a more challenging issue for risk assessment.